Hello students, this is S. Indumadi, a maths teacher from Dr. B. Gangasamy Naidu Matriculation Higher Secondary School, Arakkonam. I hope you are all safe in your home, students. Today we see the chapter Theory of Equation. First of all, before going to the class, I give some introduction about this chapter. A mathematician, Brahmagupta, was the first to solve the quadratic equations involving the negative numbers. And the Euclid, Greek, Diophantus and Ruffin, a few of the mathematicians solved polynomial equations, worked on the polynomial equations. Finally, Abel in 1823, he is a Norwegian mathematician, invented the theory of equation. Abel is a mathematician, invented the theory of equations. What is the theory of equation? In this chapter, mainly we learn about the concept of the polynomial equations, particularly the solutions. Yes, we see the few topics here. Basics of polynomial equations. In this polynomial equation, there are different types of polynomial equation. Where P is lesser than P equal to P of x is equal to an xn plus an minus 1 x power n minus 1 plus etc. plus a1x plus a0. This is the equation 1. Where A or belongs to C. C means complex numbers. Or constants. R is equal to 0, 1, 2 up to n is called a polynomial function. This is mentioned as a polynomial function. The function P defined by P of x is equal to an x power n plus an minus 1 x power n minus 1 plus etc. plus a1 x plus a0. This is the equation 1 is called a polynomial function. Already we see an x power n plus an minus 1 x power n minus 1 plus etc. plus a1 x plus a0 equal to 0. This is the equation 2 is called a polynomial equation. It equates the value of 0. No, that is called the polynomial equation. If an c power n plus an minus 1 c power n minus 1 plus etc. plus a1c plus a0 equal to 0 for all c belongs to c is called a complex numbers, then c is called a 0 of the polynomial of equation 1 and root of solution of the polynomial of equation 3. It is called the c is called the 0 of the polynomial and it is also called as the root of the polynomial. If c is a root of an equation in one variable, x is equal to c is a root, AR is called a coefficient, an is called the leading coefficient where an is not equal to 0, its value not equal to 0, it is a non-zero polynomial. An x power n is called the leading term of the polynomial. And then a polynomial with the leading coefficient is called a monic polynomial. A polynomial with a leading coefficient is called a polynomial. Polynomial has so many types. There are few types we have to see here. Suppose a constant 0 is called a 0 polynomial. Only the constant term only appeared. Some other constants only appear. This is called a constant polynomial, that is a 0 polynomial. Polynomials of a degree 1 is called a linear polynomial. Polynomials of degree 1 is called a linear polynomial, that is a degree x power is equal to 1, x plus 1. Example x plus 1. It has a power 1. This is called the linear polynomial. The polynomials of degree 2 is called a quadratic polynomial. The polynomials of degree 2 is called a quadratic polynomial. Example x square minus x plus 2. What is called a degree? The highest power of the polynomial is called a degree. Here what is the highest power here? Here 2, here 1. 2 is the highest number, so it is called the degree of the polynomial. So the degree of the polynomial having a 2, it is called the quadratic polynomial. Polynomials of degree 3 is called a cubic polynomial. For example, 4x cube plus 4x square minus 5x minus 3. Here highest power is called 3. It is called the cubic polynomial. The polynomials of degree 4 are called quartic polynomials. That is the power in the polynomial. The highest power 4 is called the quartic polynomials. For example, 3x power 4 minus 6x cube plus 3x square minus 2x plus 2. Here the highest power is called 4. That is called the quartic polynomials. In lower lower classes, already we see the quadratic equation. It is in the format ax square plus bx plus c equal to 0. That is the quadratic equation. So its discriminant is denoted by del. Del is equal to b square minus 4ac is equal to del, but del is equal to minus b plus or minus root of b square minus 4ac by 2a, where beta del is equal to 0. Del is, here three conditions in the discriminant. Del is equal to 0 is called if and only if the roots are equal. The two roots are equal, that is called del equal to 0. Del is greater than 0 if and only if roots are real and distinct. Roots are real and distinct. Del is lesser than 0 if and only if no roots. There is no real roots, that is called the del is lesser than 0. So the discriminant is having a three conditions to solve the problems in the quadratic equation. In this exercise, in this chapter, we mainly see the beta's formula for the quadratic equations. It also having the quadratic formula also and also the cubic formula also. First of all, we see the quadratic equations. Beta's formula for the quadratic equation. The highest power having a 2 is called the quadratic equation. So here given alpha comma beta, here are the roots they are given. Ax square plus bx plus c is equal to 0. Ax square plus bx plus c is equal to 0, where a into x minus alpha into x minus beta. So multiply the values here. A into x square, ax square minus a into alpha plus beta into x plus a into alpha beta is equal to 0. That is called the quadratic equation for the beta's formula. Here we find out the value. Alpha plus beta is equal to sum of the roots. It can be considered as the sum of the roots. It is the sum of the roots, where sum of the roots alpha plus beta is equal to minus b by a. This is a formula for the sum of the roots. This is the product of the roots. We multiply the two roots, that is alpha, another is beta. So alpha beta is equal to c by a, where so the quadratic equation may be given as x square minus alpha plus beta into x plus alpha beta equal to 0. This is the quadratic equation of the beta's formula. X square minus alpha plus beta into x plus alpha beta equal to 0. And then based on this topic, we see one example. Example 3.1. What is the question given there? If alpha and beta are the roots of the quadratic equation 17x square plus 43x minus 73 is equal to 0, construct a quadratic equation whose roots are alpha plus 2 and beta plus 2. There are the two roots are given there. They given the quadratic equation 17. If alpha beta are the roots of the quadratic equation, what is the question given there? 17x square minus plus 43x minus 73 is equal to 0. Here a is equal to 17. X square coefficient is called a. So a is equal to 17. B is equal to 43. X coefficient is called b. So b is equal to 43. C is equal to minus 73. What is the constant term given there? Minus 73. So C is equal to minus 73. First of all, we see the two formulas. Sum of the roots alpha plus beta is equal to minus b by a. Alpha plus beta is equal to minus b by a. So minus 43 by 17. Product of the roots alpha beta is equal to c by a. So minus 73 by 17. We have to find the two values alpha plus beta and alpha beta. What are the roots given in the question? Alpha plus 2 and beta plus 2. Now we have to find that values. Given roots are alpha plus 2 and beta plus 2. Alpha plus 2, beta plus 2. Same like we have to find out the values. Alpha plus beta is equal to alpha plus 2 plus beta plus 2. Add this values 2 and 2. Alpha plus beta plus 2 plus 2, 4. 2 plus 2, 4. Already we find out the value alpha plus beta. Alpha plus beta equal to minus 43 by 17. We know the value for alpha plus beta. Alpha plus beta is equal to minus 43 by 17 plus 4. Here we cross multiply the number. 17 4s are 68. 17 4s are 68 minus 43 plus 68 by 17. So shall we subtract the numerator? Minus 25 plus 25 by 70. 68 minus 43 plus 25 by 17. This is the value of alpha plus beta. This is the value of alpha plus beta. Next we have to find out the product of the roots alpha beta. Alpha beta we have to find out the product of the roots alpha beta. So multiply the given roots alpha plus 2 into beta plus 2. Alpha plus 2 into beta plus 2. Multiply the values here. Alpha into beta, alpha beta, alpha into 2, 2 alpha, 2 into beta, 2 beta, 2 2s are 4, 2 into 2, 4. So multiply the values. So listen, alpha taking a 2 common here, alpha beta plus 2 into alpha plus beta plus 4. So alpha beta we have to find out the value alpha beta. Already we know what is the value for alpha beta minus 73 by 17 plus 2 into what is the value for alpha plus beta minus 43 by some substitute here minus 43 by 17 plus 4. Okay, multiply the 2 with this number. 2 3s are 6, 2 4s are 8. So minus 86 by 17 plus 4. Minus 86 by 17 plus 4. Remove the brackets minus 73 by 12 plus into minus plus into minus minus 86 by 17. This is the same values. No, this is the same symbols. Add this the numerator. Minus 73 minus 86 by 17 is equal to minus 159 by minus 159 by 17 plus 4. And then here minus 159 by 17 plus 4 here cross multiplication minus 159 plus 17 4s are 68 by 17. Subtract the numerator minus 91 by 70. This is the alpha beta value. This is the alpha beta value. So the quadratic equation with required roots is x square minus alpha plus beta into x plus alpha beta is equal to 0. This is a required equation. X square minus alpha plus beta into x plus alpha beta is equal to 0. Shall we substitute the values here? X square minus, what is the value of alpha plus beta? 25 by 17. Alpha beta is equal to minus 91 by 17. So x square minus alpha plus beta. So 25 by 17 into x plus minus 91 by 17 is equal to 0. This is considered as the equation number 1. This is considered as the equation number 1. Multiply the equation by 17. Multiply the equation 1 by 17. So multiply in each terms 17x square minus 17 into 25 by 17 into x plus 17 into minus 91 by 17 is equal to 0. So 17 get cancelled, 17 get cancelled. So the remaining equation is 17x square minus 25x minus 91 is equal to 0. This is the required equation having the roots alpha plus 2 and beta plus 2. This is the required quadratic equation having the roots alpha plus 2, beta plus 2. I hope you are all understood, students.